In this video, we'll explore profit and loss situations of a perfectly competitive firm. A firm is faced with horizontal consumer demand curve, perfectly elastic demand. This is because each firm is a price taker. It can sell any quantity it wants at the market price but cannot influence the price. However, the market demand curve is the sum of all individual consumer demand curves in the industry. Therefore, it retains the typical downward sloping shape, reflecting the law of demand. As price decreases, quantity demanded increases.
Here we define market demand and corresponding marginal revenue curve. Note that the slope of marginal revenue is twice the slope of demand curve, 0.5 versus 1. Total revenue is price times quantity, and rule of differentiation multiplies 2 and 0.5 equal to 1. By equating demand and supply, we solve for equilibrium quantity of 15. Plugging this into either demand or supply equation gives equilibrium price of 12.5. Let's do it graphically. Interaction of demand and supply in the A. Market determines equilibrium quantity and price. For this particular situation, equilibrium quantity is 15 units of the good. Units could be in hundreds, thousands, or millions according to the data measure. Likewise, equilibrium price is 12.5 units. Units could be in any currency, in hundreds, thousands, or millions according to the data measure. This is horizontal demand curve at the given price. That's how a single perfectly competitive firm perceives it. Each firm is a price taker. Therefore, perfectly elastic demand curve indicates it can sell any quantity it wants at the market price of 12.5, but cannot influence the price by the quantity it brings to the market because it is negligibly small quantity.
To maximize profit, a firm equates marginal revenue to marginal cost. Why? Let's look at it. Assume price is 80. Total cost is sum of fixed and variable cost given by this total cost function. Marginal cost is derivative of total cost with respect to quantity. Equate the two and solve for equilibrium quantity level, which is 28.93 units. Check that marginal cost at this equilibrium quantity is 80, equal to price or marginal revenue. The equality of marginal revenue and marginal cost means that the addition to total cost for the production of an additional unit is exactly equal to the addition to total revenue earned from selling the unit. For the production level less than this, to the left adds more to total revenue than the cost added to total cost, so more must be produced and sold. Likewise, level greater than this, to the right, adds more to total cost than the revenue added to total revenue, so less must be produced.
To these two curves of marginal revenue and marginal cost, next we add two more cost curves. Short-run average total cost, or average total cost, is given by this quadratic function. Short-run average variable cost is given by another quadratic, Function. Note that marginal cost curve intersects two other cost curves at their minimum. In fact, these minima are very important from profit and loss in the short and long run. When price level is below minimum average total cost, firm incurs loss. Let's find these minima points.
Take derivative of these two cost functions and set them equal to 0, then solve for quantities. Average total cost is minimum at 25 quantity level, and average variable cost is minimum at 15 quantity level. Solving. These functions at their respective quantities give their cost levels 60 and 30, respectively. We can show these points on the diagram. Take note of the fact that a price line given by the competitive market can fall anywhere above, below, or between these cost curves. When price line is above minimum of average total cost, firm enjoys economic profits, also called supernormal or positive profits. When price line is tangent to the minimum of average total cost, firm gets zero profit, also called normal profit.
When price line falls in between two minima, firm incurs loss, but still operates for what is called as loss minimization. How long it can sustain losses. To produce, it has to think in terms of fixed cost and average variable cost. Fixed cost is also known as sunk cost. So it is variable cost, which may be saved by stopping production, not fixed cost, which is already incurred at the start of the production process. If price and revenues are at the level that the variable cost can be covered, firm continues to produce and sell to minimize losses. If price line falls below the minimum of average variable cost, it is better for a firm to shut down and stop production. This is to minimize loss. In the case of loss, when price is above minimum of average variable cost, but lower than average total cost, the difference of price and average variable cost contributes in lowering the fixed cost loss. When price is lower than the minimum average variable cost, there is no such contribution to reduce fixed cost loss, so it is better to stop production.
As an example, in this diagram, with given price of 50, per unit analysis shows that even though 60.47 minus 50 equal to 10.47 is loss, 50 minus 32.88 equal to 18.88 is the contribution towards reduction of the fixed cost. For the price below the minimum of average variable cost, shutdown is usually temporary in the short run. If firm waits and sticks to the industry and prices rise, in the long run, the equilibrium price would be equal to the minimum of short-run average total cost, which is also the minimum of long-run average total cost. These two cost curves are tangent at this point, and price line is tangent too. Normal or zero profits are made in the long run.
Now we look at total profit calculations. In this diagram, price level is 80. It crosses average total cost above its minimum point. The point of equilibrium is where marginal cost intersects marginal revenue. The coordinates are 28.93 and 80. This is equilibrium quantity-price pair. Area of the green rectangle is the total profit. From the corresponding points as indicated, rectangle length and width are determined. The product of these is the total profit. Area of the yellow region is total cost. Sum of area of both rectangles is the total revenue. From the intersection of equilibrium point, we drop perpendicular to average total cost curve and extend it horizontally towards y-axis and straight down towards x-axis. Here, exact values of the relevant points are calculated algebraically. These are equations of different cost curves.
Here we solve for the equilibrium quantity from the equality of marginal cost and marginal revenue. Plug the equilibrium quantity in the cost equation to determine its value for the equilibrium quantity produced. Length and width of rectangle is found here. Multiplying them gives the area of the green rectangle, 542.85. This is the profit.
Here we find the area or profit through integration. First part of integration is the area under the price line till equilibrium quantity. This is total revenue. Second part of integration is area under the line determined by the point of intersection of perpendicular from equilibrium point to the average total cost. It is yellow color shaded area, which is total price. The difference of these areas is the total profit, which again is 542.85. This is the scenario of total loss calculation. It can be calculated as area of the red region. This animation shows the profit and loss situations with green and red rectangles. Notice how the size of rectangle changes because of different prices and its interaction with marginal cost curve.